Welcome to VINDAL'S concept. Welcome to VINDAL'S concept. And this is a physics class, and I want us to look at a few kind of questions that we see in Igcse, and which is exactly simple harmonic motion. Then I am going to paste a video for you to watch on the video clip, and when you watch that on the video clip, you're going to be seeing that this question is exactly as it was explained here. Now, it says that a mass loaded spring is displaced 5 centimeters below its equilibrium position and released. It travels from the lowest point to the highest point within 0.3 seconds. That means it travels from the lowest point, that is from this point, it travels to the highest point, that is reaching here, in 3 seconds. Remember that this place is time. We are recording time at this horizontal, and on this vertical, I'm recording meters, right? Now, so when this goes this way, returns to this way, we say that it has completed one oscillation, and the time is recorded on this horizontal axis. If this is 0 centimeter, then this is going to be, at this point, we have 1/4. So this is half, right? And this is another, this is 1/4. That is from here to here is 1/4. From here to here is another 1/4. Then 1/4, 1/4, 1/4 is going to give you a half. Then this one is going to be, this is going to be 0.3 because it's half. Then this is another 1/4, and then half of this is 1/4, and this place is going to be 0.6 seconds. What I mean is that for a complete oscillation, we are going to have 0.6 seconds. What I mean is this. Remember, we started from here and released. It goes to this place at 0.3 and comes back here, 0.3. So, and the one complete oscillation is equal to a circle. That means 1/4, 1/4 is half. Another half, then, and then, 1/4, 1/4, 1/4, 1/4. Remember that for you to have a full circle, you are going to have 1/4, 1/4, 1/4, 1/4. So 1/4 in 4 places will give you a total of a complete circle. And that is what we mean by one oscillation. That is a complete oscillation. A complete oscillation. Now, a complete oscillation means that this has made 360 degrees, and this is where it should terminate. So in that case, I'm going to say that T period is 0.6 seconds. All right? 0.6 seconds. Now they said, determine the maximum time or the minimum time required for the system to oscillate from 5 cm below its equilibrium position to 3.0 centimeter above the equilibrium position. Now look at this. This is +5. That means from the origin, it goes to this 5. That is the highest point, and it is called the amplitude. Then it goes below it in the negative amplitude. Remember, in life, things must balance. If you give out +5 on the up, on the positive direction, you must give out negative on the negative direction. And that is all about life situations. Life must balance. All right? So, now they want me to find the time when it has gone 3 centimeters above its equilibrium. If this equilibrium position, at this point, we may say that something like this is going to be 3 centimeters. All right? Now, what will be the time at this point? Remember, maybe at this point, what will be the time here recorded? And that is what we want to look at. Maybe at a point here, that is what we are going to look for. Now, I have found the period. Now, remember that every equation, a general equation of any simple harmonic motion is sinusoidal, or we can use cosine function. So I'm going to say that it is given as x is equal to x sub naught. I'm using x sub naught. Yes, I'm using x sub naught as the maximum height. So I'm using x sub naught cos omega t. All right? Or I can also say that it is given as y is equal to a cos omega t. Y is the vertical axis. T is the horizontal axis. A is the amplitude, which is +5. So at this point, since I'm using y on this vertical axis, so the question is, at what distance on this vertical direction from here to this point, from here to this point, and at what time? So if you notice, the two major factors is the y-axis and the time. So I want to consider this and this, but this is actually 3. So I'm going to write 3 is equal to 5 is from, because it started from here and go up. So I'm using -5 cos. The next thing I want to find is omega. Omega is theta over time. That is angular velocity, which is the angular displacement over time taken. Now, what do we see? Since this thing is a complete oscillation, one complete oscillation is given as 2 pi radian, or 360 degrees. That is a full circle, makes 360 degrees. However, in this context, physics, we don't usually use it in terms of degree. We use it in terms of 2 pi radian, in terms of radian. So I'm going to say omega is 2 radian all over the time period. The time taken to reach half is 0.3. Therefore, the time taken to reach complete is 0.6. That's 2 times this is 0.6. So I'm going to have 0.6. So coming in here, I'm going to put 2 pi all over 0.6 with respect to t. That is multiplying by t. Then what I'm going to do is, say 3 minus 3 over 5 equal to cos 2 pi over 6 over 0.6 t. All right? So, and then I have to divide both sides by cos. So at this point, I'm going to have cos inverse of -3 over 5. Which is equal to 2 pi over 0.6 t. So if you do your trigonometry very well, cos inverse of this is going to give us 2.21 equal to 2 pi over 0.6 t. Therefore, I want to complete it here. Therefore, t is going to be 0.21 seconds. So the time at this distance, the time it's covered, it's 0.21 seconds. Thank you for being part of this class. Remember to follow some of my socials and remain blessed.